Hello students, this video session we are going to see how we can insert at the end of a circular linked list. Okay, in the last video session we had seen how we can insert at the beginning. Now let us see how we can insert at the end. Let me take an example. I told you already. Suppose let us say the first condition that we are going to check is if my linked list is going to be empty. So if my list is empty, that means you have a pointer head. Okay, this pointer is going to point to null. That is how we try to check. If head is equal to null, that means it is empty. Circular list is empty. Now the new node, this is a new node that I want to, let me call it as new node because I will also be coding it like that. This is a new node that I want to insert. Now, if I want to insert, suppose I am taking some value 23. I want to insert this particular node at the end. Okay, insertion at the end. If the list is empty, this will be the only node that I will be inserting. Correct? So, what I can write if head is, that means this will be the only node. Head should now point to this particular node. Correct? Because this is the only node, it will no more point to none. It is not null. You cannot initialize it to null now. This head is going to point to this node. What will happen to the next link? This will come back here. Same thing that we saw in the insertion at the beginning. This, if the list is empty, at insertion at the beginning, at the end, everything is same because your list is empty. This is the only node that you will be inserting. That is one condition. Second condition is what? My list is not empty. Then what will happen? Now, if my list is empty, this is how my head will start pointing to the new node. Next of new node, it will again come back to this because it is a circular linked list. Okay, now if my list is not empty, now we will take one more example for it. List is not empty means let me draw one more linked list which is not empty. First I will show you pictorially, then we will go to the code. Linked list. Second condition, what I said, it is not empty. But, so it is not empty means I have some nodes here. I want to insert at the end. Okay. So that how do I check if a node is the last node or not? I have to come up to here. This is my new node. This is a new node. Some value, let us say 20. I want to bring this node at this point. What are the changes that will happen? This which is connecting here, that will not be there anymore. This has to connect here. This new node has to come back here. That is the change. This will not happen. That is the change that is going to happen. Are you getting me? List is not empty and I want to insert at the end. This is a new node that I want to insert. So this entire node has to come at this point after this node. 17, 20 will become the last node. So what are the changes in terms of link? This which is pointing back to your head node should not be there. Next of the 17 should point to 20. Next link of 20 should come back and point to head. This is the change that you have to make. Correct. Now how can I make that change? What I can write? I have to somehow, the change is happening here. Somehow I should be able to access this node, that is 17. How can I do that? I will take a variable called as temp. Now when I take a variable called as temp, I initialize it to head. That means it is initialized to head. It will start from here. I will go on checking whether each node, whether it is the last node or not. Because once it is the last node, that is where I have to insert. How do I check whether a node is the last node or not? I can check with respect to the next link of every node. If the next link is pointing to head, that is the last node. That's how we check. So what happens? I will check whether link next of this 23, is it pointing to head or not? It is not pointing because it is pointing to the next node. So temp is equal to temp of next. So that means this will become temp next. Again I will check whether next link of this temp, is it head pointing to head or not? It is not pointing. So temp is equal to temp of next. So now this will become temp. Whether temp is next of temp is temp of next. is pointing to head or not? It is not pointing because it is pointing to 17. So temp is equal to temp of next. I'll come here. When I come to the last node, temp of next is pointing to head. Correct? Initially it is pointing to head. So I'll come out of the loop. Now what I should write? This temp of next should be your new node. New node of next should come back to your head. Are you getting me? So that is how we are going to code this particular, this particular coding. Are you able to understand? Insertion at the end, two cases we do. One, when the list is empty. The second thing, when the list is not empty, that means you have some nodes and then you are going to insert the node at the end. Let us see now how we can write code for this. Okay. Now let us look at the code. I had taken circular SCIR LL as the class I had declared it. So I am using scope resolution operator insert end. Parameter I am passing as value. So this value has to be passed from the main function when you are calling this particular function. Okay. So what I told you, we are going to, my new node is called as new node only. So this is the new node that I have. New node. I call it as new node. Okay. Some value is there 23. Now, new node, I am allocating memory for that. New node of data is equal to value. So whatever value you are accepting, that I am assigning it. This is my new node of data. This is new node of next. Okay. Now, the first condition, what did I told you? I told you that if the list is going to be empty, then this node itself will become the first node. Okay. How do you check if the list is empty? I am going to say if head is equal to null. So if head is null, head is equal to new node. That means head will point, currently head is not pointing anywhere because there are no nodes at all. This is the first node that you are going to insert. So whether you insert beginning or end doesn't make any difference. Head is equal to new node means head is going to point to the new node because head should always contain the address of the first node. So new node. Then new node of next is equal to head. This is a circular linked list. Now new node of head, new node of next. New node of next is this one. Should again come back to new node or it should come back to head wherever head is pointed. This will happen when the list is empty. Now, if the list is not empty, I have, that means what? I have so many nodes and I want to insert it at the end. So I am taking a pointer called as temp. I am initializing it with head. Okay. So I already told you how we can do that. You can, okay, this is head. It is pointing to the first node. I am having it like this. You can refer, I had already told all this. So you are taking a new pointer called as head, while temp of next is not equal to head. I want to insert at the end. So I have to come up to this location. My new node, it should come here. So this pointer will go. This pointer should come here. This should come to the head. Right? So what we are running. So how do I come up to the last node? I will check if temp of next is not equal to head, temp is equal to temp of next. I have initialized this as my temp. Currently this is temp. Temp of next is not equal to head. Temp of next is pointing to this node. So it is not head. So temp is equal to temp of next. So now this will become temp. Next. Again I go back. While temp of next is not equal to head. So it's not equal to head because it is pointing to this next node. So this temp is equal to temp of next. So this will become temp. Now again I go back. While temp of next is not equal to head. Now here what happens? Temp of next is equal to head. It is pointing to the head. So it will come out. How do you write this? This has to come here to the new node. That is temp of next will be equal. This is what? Temp of next. It should come to the new node. Correct? New node of next should come to head. New node of next should come to head. So that is how you are trying to implement or trying to insert a node at the end. So there are two conditions that we have checked. One is if the list is empty, how do you insert? If the list is not empty, then how do we insert it at the end? Next, let us see how we can try to display a circular linked list. Okay, now I want to display. Suppose that before looking at the code, just look at this example. This is the circular linked list that I have. How will I display this? If I want to display, I will display it as 23, 17, 40, 15. Since it is a circular linked list, this is coming back here. So again I have to write 23. It starts with 23 and ends there again. It is a circular. That is why we should always display it as 23, 17, 40, 15 and again 23. This is how you should display for this particular circular linked list. Now, first thing what I have to check, look at this part. If my list is empty, I cannot display anything. So, how do I check that? If head is equal to null, then list is empty, over. So, that is the first condition you have to check whenever you want to display the circular link, whenever you want to display anything. If it is a, the empty list, you cannot display. So, list is empty, deletion is not possible. Next, if it is not empty, then this is the case wherein I have some elements to display. So, what am I doing? I have to go on displaying each one of them, 23, 17, 40, 15 and again I should come back, display 23. So, I am taking one pointer temp and I am initializing it to head. So, this will become my temp. What are we checking? While temp of next is not equal to head. This condition, if temp of next is equal to head means what? Temp of next is equal to head means we are referring to the last element. As long as that means you have to display everything up to that. So, I have to have that condition. So, while temp of next is not equal to head, see out temp of data. So, first we have initialized temp is equal to head. So, temp is here. Temp of next is not equal to head. Is it equal to head? No. It is pointing to the next element. So, when this condition is satisfied, we come here. See out temp of data. See out temp of what is temp of data? Temp of data is 23. So, I will display that 23. Then, I am just putting here. So, I am going to display temp of data. Then, I am just putting an arrow. I want that arrow to be displayed so that it looks like a linked list. Okay. Next, after I display, I will do what? Temp is equal to temp of next. So, temp is equal to, this is my temp. Temp is equal to temp of next means this will become the temp next. This is not the temp anymore. Again, I will go back. While temp of next is not equal to head. So, temp of next, this one, is it pointing to head? No, it is pointing to the next element. So, condition is satisfied. So, it will come here. See out temp of data. This is my temp. Temp of data is 17. So, it will display 17. After 17, what you are displaying? You are displaying an arrow. This arrow gets displayed. Again, you go back. While temp of next is not equal to head. Okay, after you do this, temp is equal to temp of next. So, this will become temp now. Correct? Now, your temp is equal to temp of next. You will go back again. Temp of next is not equal to head. Temp of next is pointing to 15. It is not pointing to head. So, condition is satisfied. You will come here again. See out temp of data. What is temp of data? 40. So, I will display 40. Temp is equal to temp of next. I will display 40 and that arrow. Then, temp is equal to temp of next. So, again, this will become temp. Again, I will go back. While temp of next is not equal to head. Now, what is happening? Temp of next is this. Is it equal to head? It is equal to head. It is pointing back to head. So, this condition is not satisfied. So, it will come out of the loop. It will come out of the loop. I have still not printed 15. So, I will say, see out temp of data. So, I will print 15. Then I will put an arrow. I will also display head of data. Head of data is what? 23. So, I will get this kind of display to be done. Is it clear? So, we are checking two conditions. First thing, if it is null, that is if it is empty, we are not going to display anything. If it is not empty, we take a pointer, we go on displaying until we reach the last node. When you reach the last node, you should also display head of data because it is a circular linked list. So, this indicates, this finishes with insertion at the end and display. Next video session, I will again tell you how to insert at any particular point. Okay, that will take up in the next session. Thank you.